Hello, Math Grade 7 students. Today we are going to be looking at some review problems on solving equations and also setting up equations from word problems, real life scenario problems. And so, number one is making fun of Mr. Underkoffler. Go figure. All right, take a look at this. It says, in a study last week, 3/8 of the students surveyed said Mr. Underkoffler is too loud. Oh, the horror, how dare they? And then it says 48 students gave that response. Which equation could be used to solve for the number of students who were surveyed? My suggestion to all of you to be able to figure out if this is A, B, C, or D is use the skills that we have learned. Remember how we used to define a variable? Now, obviously, I'm picking S if you look at A, B, C, and D, but do you know what the S stands for? It's important that you figure that out. And then you should go back and reread the sentences and see if you could translate piece by piece to figure out then which equation actually makes sense. Hit pause on the video, try that right now, then hit play when you're ready to see how you did. All right, I hope you have already figured out on your own which equation made sense. The first thing I recommended to you is to figure out what the variable even represents. And the way you can do that is by rereading the part where it tells you what they want you to find. The last sentence normally tells you that. It says which equation could be used to solve for, okay, here we go. It's going to tell us what we're going to be solving for, the number of students who were surveyed. So that's what the S represents. It represents the number of students who were surveyed. That does not mean the 48 students who said Mr. Underkoffler was too loud. That means the total number of students who were surveyed. Here's why this matters. If you know what words represent the variable, then when you go back and you start translating the sentences piece by piece into what they mean mathematically, then you'll see the words that represent the variable, and that will help you to know where the variable should go. Let me show you what I mean. Rereading the first sentence in a study last week, 3/8 of. Now I'm going to stop right there. We know 3/8 means 3/8. But when you have a number and then immediately after it you have the word of, then the word of actually means something mathematically. And you might want to jot this down. This is something we haven't talked about in a while, but it could definitely be showing up on a quiz or test. When you have a number followed right away by the word of, then the word of means to multiply by that number. So 3/8 of mathematically means 3/8 times. Well, then that eliminates choices A and B. They make no sense at all because 3/8 of means 3/8 times. Times what? The students surveyed. Whoa, 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 whoa. Didn't we already figure out from the last sentence that the number of students who were surveyed is what the S represents? Yes. Well, then 3/8 of the students surveyed means 3/8 of the S. And of means times. So we should have 3/8 times S. Ding, 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 ding. It is choice D. Because choice C has 3/8 times 48. That's not what the first sentence said. The first sentence said 3/8 of the students surveyed, and the students surveyed is our variable. And that's why it's 3/8 times S. And then that would equal the 48 students who gave the response that they gave of Mr. Underkoffler being too loud. How dare they? Okay, so that is how you can use your translating skills to do a multiple choice problem. It's not multiple guessing. Use the skills I taught you. make sure you know what the variable represents. That's why we used to define the variable. Then reread the sentences and translate piece by piece, and that should lead you to figuring out which equation makes sense. So now that we have figured out which equation makes sense, I would like for you to solve this equation using inverse operations on both sides. Hit pause in the video, show the work, solve this equation. You may use a calculator to help you, then hit play when you're ready to see how you did. Okay, I hope you have already solved this on your own. You had to ask yourself, what's happening to the variable? The variable was being multiplied by 3/8. How do I know it was being multiplied? You're like, Mr. Underkother, I thought fractions mean division. Well, 3 over 8 means 3 divided by 8. But what's happening to the variable? The variable is s. When a number is next to a variable, that means multiplication. So since the 3/8 is next to the s, that's why when I answer what's happening to the variable, which is the s, I would say it is multiplied by 3/8. Why does that matter? Because the inverse of multiplication is division. And so that is why you should divide by 3/8 on both sides. Now, if you were not using a calculator, you would have to do this thing called multiplying by the reciprocal, which is how you learned how to divide fractions back in like 6th grade math. But since you're using a calculator, you can just keep it as dividing by 3/8. 48 divided by 3/8 is 128. If you did not get that, if you got some crazy fraction, like 1 over 128, then that means you did not enter the problem in your calculator in the correct order. It's 48 first, then divided by 3/8. You cannot switch the order of division. You must punch it in that order. That's how you get 128. And then, of course, the left side gives you 1s because anything divided by itself is 1. We do not need to punch in our calculator 3/8 divided by 3/8. That would be a waste of your time. You should already know it gives you 1. Any number divided by itself will give you 1. And then, of course, 1s is the same as just s, and that's how you get the variable by itself. Oh, look. The final answer has a unit of measure. Now, how did I know it was going to be students? Because the problem said, which equation could be used to solve for the number of students? That's why the final answer is not just 128. The final answer is 128 students. Yes, that matters. Yes, that would be required. Otherwise, you would lose a half point on a test or quiz. All right, let's look at another word problem. Number 2, I will read it out loud. Follow along. It says Hector was given a $125 gift card to a local movie theater. Each time he used the gift card to watch a movie at the theater, $11.75 was taken off the value of the gift card. Which equation could be used to find the number of movies Hector watched if his remaining balance on the card was $19.25? So again, if I were you, I would make sure you know what the variable represents. That's what we used to call defining our variable. And then if I were you, I would go back, reread the first sentence, translate what it means mathematically. Reread the second sentence, translate what it means mathematically, and continue doing that even into the third sentence, because that even had a number involved as well. And then you should be able to figure out which equation is correct. Hit pause on the video, do that now. Okay, I hope you already figured out which one made sense. If I'm going to define my variable, I need to know what the problem was asking me to find. The problem was saying which equation could be used to solve to find the number of movies Hector watched. So the m in these equations represents the number of movies. Now keep that in mind when we go back and we start translating the sentences piece by piece. The first thing it said is Hector was given a $125 gift card. Well, choices A, B, C, and D, they all start with the 125, so I guess we need to keep going. Each time, now the word each often means to multiply. Let's keep going. Each time he used the gift card to watch a movie at the theater, $11.75 was taken off. if it's taken off the value of the gift card, which means taken off the 125, then taken off means to subtract. And that means we can eliminate choice A and choice B because they are not subtracting. They're somehow increasing, adding to the $125 gift card. I wish we could add to our $125 gift card, making it more valuable, but that makes no sense on this problem. Each time he watches a movie, $11.75 was taken off. That means to subtract. So we are now left with choice C or choice D. Now, they both equal 1925, and of course the last sentence says was 1925, so that means equals 1925. But we have to figure out, should it be 1175 times the number of movies, or should it be the number of movies divided by 11.75? Which is the way that it would happen in real life? If it's 1175 for each time you watch a movie, wouldn't you take the number of times you watch a movie times the cost of each movie and then subtract that away from 125? Yeah, you would. And like I said a minute ago, the word each kind of gave you a hint that multiplication is probably going to be involved. But the real reason that choice C is the correct answer is because it's the one that makes sense in real life. In real life, you would take 1175 times the number of movies you watched and then subtract that from 125 to figure out that your remaining balance is whatever it ends up being, in this case 1925. That's the way it works in real life, then that's the way it should work for your equation. All right, since you have that equation now figured out for this problem, I want you to solve it using inverse operations on both sides. Now you will notice there's two things happening to the variable, so you're going to have to figure out what's happening to the variable first and second, and then figure out the inverse operations first and second. So hit pause on the video and solve this equation right now. Okay, I hope you have already solved this on your own. If not, you better hit pause now. All right, so here's the deal. You have to figure out what's happening to the variable. And the variable, where is it? The variable is, oh, it's over here. Ooh. That's 11.75m is to the right of the subtraction symbol. What's happening to the variable? Well, I guess I could say it's multiplied by 11.75, but am I allowed to read backwards and say that the variable is secondly being subtracted by 125? No. No. Subtracting from 125 is not the same as subtracted by 125. That is not going to help you. You cannot read backwards with subtraction. So ladies and gentlemen, whenever the variable is on the right-hand side of subtraction, you need to make the subtraction become adding the opposite at the very beginning. And that's why we would say the variable is multiplied by negative 11.75, and then it's being added by 125. Yes, you can read backwards with addition. You would not have been able to read backwards with subtraction. I have a feeling some of you forgot about this, that you have to make subtraction out of the opposite first when the variable is to the right of the minus. I bet some of you forgot that. So that means you should probably hit pause on the video again if you need to. Because if your inverse operations, now you realize they're totally wrong because you messed up with figuring out what's happening to the variable, then you have a lot of stuff to fix and redo. So hit pause on the video if you need to, fix your mistakes, fix it in your work, then hit play when you're ready to see how you did. Okay, for those of you who needed to fix your mistakes, I hope you have already taken the time to do that. Your inverse operations should be this. You should subtract by 125 first, because when you will have two inverse operations, they need to go in the opposite order from what was happening to the variable. That's why you start with the last thing that was happening to the variable and inverse that first. Then later, you will do the inverse of what used to be the first thing happening to the variable. What's first will be last. What's last will be first. That's what inverse means. You do the opposite. Okay, so we just got done saying that the first inverse was to subtract by 125. So we're going to do that underneath on both sides. And you need to line it up properly. Do not put the minus 125 on the left underneath the negative 11.75 m. That would make no sense. You're inversing the adding by 125. So that's what it should be lined up underneath. And then, of course, it needs to be underneath on the right-hand side. 125 take away 125 is 0. I'm going to be honest with you guys. There's probably a point now where we should stop putting that 0 step. I mean, because I don't think we really need it that much anymore. So if you're at the point now where you're like, Mr. Undercoffin, do I have to show the plus 0 step? You know what? I'm cool with you not needing to anymore if you don't want to. Right-hand side, 19.25 minus 125. I'm assuming you probably used a calculator for that. That's going to give you negative 105.75. And now we need to do the second inverse operation. The inverse of multiplying negative 11.75 is to divide by that same number. So you should divide by negative 11.75 on both sides. Make sure you have the negative signs. A negative divided by a negative will give you a positive. Oh, by the way, negative 11.75 divided by itself would give you 1. Yes, I used to make you show that 1 step. But I think you're at the point now where you should realize when you get 1m, that's just the same as m. So you don't really need to show that anymore if you don't want to. The final answer is 9 movies. How did I know that the unit of measure was going to be movies? Because the problem asked me to find the number of movies that Hector watched. So that's why the final answer must have the word movies with the 9. Not optional. All right, problem number 3 for today. This is not a word problem, but this is one of these equations that has parentheses. Solve this equation on your own. So hit pause in the video, solve this on your own, then hit play when you're ready to see how you did. All right, I hope you already solved this on your own. Let's see how you did. Did you remember that when there is a number outside of parentheses with nothing in between the number and the parentheses, then that number, in this case the 24, is multiplied to the parentheses. And so that should make you be thinking about the distributive property, where you're going to take the 24 times the n, but also times the 11. And so that would make it 24n minus 264. Now, if you're like, oh yeah, I kind of forgot to do that. Well, then that means you have a lot of stuff to fix, don't you? And I should tell you once again, hit pause in the video and fix whatever you need to fix. All right, I hope you did that if you needed to. If not, hit pause now. If you ask yourself what's happening to the variable, and yes, I'm abbreviating here because I got tired of writing out the full question. The variable is being multiplied by 24, then it's being subtracted by 264. We will go in the opposite order of that, so we will add by 264 first, and later we will divide by 24. So let's go ahead, add by 264 on both sides. If you now would like to make the subtraction here become adding the opposite before you work down, feel free to, because now you will hopefully realize that negative 264 plus positive 264 would give you 0. Now, I had told you on number 2, if you don't want to show the 0 step anymore, you don't need to. You can go straight away to saying that that's just going to give you 24n on the left-hand side of the equal sign. The right-hand side, when you have a negative plus a positive, you subtract in your head. Now, I'm not going to kid myself. You probably used a calculator for that. So that's going to give you the 8.76. Now, we're not done. The variable is not by itself yet. It's still being multiplied by 24, and that's why it's now time to do the second inverse operation, which is to divide by 24 on both sides. Now, you can't punch the order of division in the backwards order in your calculator. This should be 8.76 typed in first, then divided by 24. If you punch it backwards in the wrong order with a 24 first, then you are not doing it correctly. You will get a decimal, and I know so many of you students are used to thinking that if you get a decimal, that you guaranteed must have done the problem wrong. Not anymore. Decimals are fair game. The final answers do not have to be pretty. Not in 7th grade math, they don't, or 8th grade math, or Algebra 1 in high school, or anything like that. So stop telling yourself the final answers have to always be pretty whole numbers. They do not. Oh, by the way, 1n is the same as n. If you don't want to show the 1n step anymore, I'm fine with that. So final answer, n is equal to 365 thousandths. If you have the answer as a simplified fraction, which I believe is 70-something over 200. I forget what it is. I apologize for forgetting what that was off the top of my head. But anyway, if you have the answer in its fraction form, that would also be acceptable. All right, I would like to finish off today with 2 equations. And the reason I want to finish with these 2 equations is because every year that I give equations like these, I have students who can't remember how to determine if the variable is being multiplied by the number or being divided by the number. So let me give you a little quick review. Yes, fractions mean division, but these 2 problems are not the same. Only on one of these 2 problems is the variable being divided by the number. And that's on number 5. Number 5, the variable is in the numerator, and it is over -4. That means that m is divided by -4. So for real, if you're figuring out what's happening to the variable, it's being divided by -4. But that is not the case on number 4. On number 4, yes, fractions mean division, but that's 1 divided by 5. The variable's not in the fraction here, is it? The variable's next to the fraction. Whenever you have a number next to a variable with nothing in between the number and the variable, then that means that variable is being multiplied by that number. And so this is what is happening to the variable. It is being multiplied by the 1/5. And we know that because the 1/5 is next to the variable, which means multiplication. With that in mind, I think I've definitely done enough for you. Time for you to hit pause in the video, solve both of these equations using inverse operations on both sides, and then we'll check to see how you did. Okay, I hope you already hit pause in the video. If not, do it now, because I'm now going to go over how these problems should have worked. For number 4, the inverse of multiplying by 1/5 is dividing by 1/5. Now, if you were not using a calculator, then I would tell you that dividing by 1/5 is the same as multiplying by 5, because in 6th grade math you learned that dividing by a fraction is the same as multiplying by its reciprocal. The word reciprocal means to flip the fraction. So that's why the answer gets to be -175, is because when you take -35 and you divide it by 1/5, that's actually the same as taking -35 times 5. And that's why it actually makes sense then that you would get -175 as your result. Left side gives you 1y. If you don't want to show the 1y step anymore, you don't need to. Final answer is -175. Notice number 4 did not take nearly as much work as number 3. And it's because of number 3, there was 2 things happening to the variable, right? That's why there was 2 inverse operations. But on number 4, there was only 1 thing happening to the variable. Therefore, there's only 1 inverse operation that needs to be done on both sides. Please do not think that every single equation is going to have 2 inverse operations, because that's certainly not true. It all depends on how many things are happening to the variable. Speaking of which, number 5, I already told you the variable was being divided by -4. The inverse is to multiply by -4, and therefore I hope that's what you did on both sides. That's going to give you -128. Now, if you do not remember how in the world the left side would give you 1m, then maybe I should very quickly review that with you, because I would bet that a lot of you thought that the -4 would get multiplied to the other -4, and so you would somehow get a 16, like an m over 16. Let me show you why that is definitely not going to happen. This is something I've actually taught you before. If I take the parts highlighted in yellow and I write that out, we have m over negative 4, and we are multiplying it by negative 4. That negative 4 is the same as negative 4 over 1. And then if I multiply numerator times numerator, I would get negative 4m. That's in the numerator. And then denominator times denominator, negative 4 times 1, is just negative 4. And then you can simplify this, understanding that the fraction bar means division. And negative 4 divided by negative 4, that is how you get 1m. So ladies and gentlemen, that is why the negative 4 does not get multiplied to the denominator of negative 4. That's why you are not going to get a 16 at all on the left-hand side of this work. That is the last thing I wanted to go over with you today. Thank you for watching. We'll see you next time.